Well, ideally, we'd like to get to a place where we could also answer the question about what would be the influence of those new policies on ecosystem services. And the larger community that's working on natural capital accounting is helping to build the foundation to get there. Next slide. So for all these benefits, there are some significant flaws, and anyone who's done any work related to economic accounting, or probably even just taken an economics course in college, may have heard about this. GDP and the associated numbers, they include information about how labor and capital help to generate prosperity and economic activity, but they don't include natural resources. So there's no assumption about the soils or the crop pollinators that go into producing farm goods, or that grow into producing trees for timber harvest, or fish for harvest, much less other ecosystem services like regulating ecosystem services or biodiversity. These accounts also don't count for the depletion or damage of the environment by existing economic activity and the influences that may have on the future. And on the flip side, they don't account for the protection or restoration and the benefits that they provide. So all these environmental externalities get left out of the conventional economic accounts. And that's something that the economists who developed accounts dating back to the 1930s and 40s have known about. So this isn't a new problem or a surprise. It's sort of an inherent characteristic of how the national accounts are designed. Next slide. So in response to this, there's been a movement to figure out how we can better account for the value of nature and ecosystem services in our national accounts. And we have developed this Venn diagram through our working group to try to explain how these different approaches differ and overlap from each other. The national accounts, as I mentioned, are over here on the right. GDP is the best known of them, but there's a number of other economic indicators that are calculated regularly by our statistical agencies. Many of the people on this webinar are probably more familiar with ecosystem service assessment on the left side, and that can take a variety of different approaches and flavors. And there's a number of these approaches in the middle that are attempting to get us closer to an accounting framework. But the one that we're going to talk about today is the System of Environmental and Economic Accounts, or the SEEA. There's two pieces of this, the central framework and the experimental ecosystem accounts. And those are being developed with an explicit intent to bridge these two worlds. So to tie well to the economic data and to account for these pieces of economic value and production related to natural capital that, that our conventional economic indicators miss. Next slide. So the international response to this has been led by the United Nations Statistics Division, which is responsible for producing the statistical standards so that countries are measuring their economic accounts in the same way and that results can be compared internationally. That body has existed for many decades and has produced the standards for measuring the economy. And within more recent decades have been working on a framework to measure the environment and its importance to the economy. So I mentioned two approaches: the central framework, which accounts for things like land, water, energy and minerals, agriculture, forestry, and fisheries. Those are pieces that are already included as economic production, but the contributions of nature aren't well accounted for. So the central framework does those. The experimental ecosystem accounts are designed to address things that aren't currently included in the economically accounts at all. Many of the regulating services, carbon storage and sequestration, the value of biodiversity, all of those are addressed by the experimental ecosystem accounts. And these are increasingly being done around the world. This is an overview article that was published earlier this year, and the field is really growing and changing. Already since the beginning of this year, there have been a couple of new countries that have been added to this map. So a number of places this is already happening. The US is relatively late to the game relative to some leaders like Australia, Canada, and parts of Europe. But we play a significant role in the global economy. And by producing these and joining the international community and doing that, I think we have an important role to play in helping to advance this standard. Next slide. So our efforts here in the U.S., we were funded in 2016 by the USGS Powell Center and the National Socio-Environmental Synthesis Center. We began working with the folks at Duke University through the USGS Southeast Climate Adaptation Science Center. And we've also had support from NASA to help develop these accounts. We put together an interagency working group that included folks from a number of different U.S. government agencies like those shown here, as well as academics and some international partners. And we developed a pilot set of ecosystem accounts, one of which you'll see today. And since developing those accounts, which are in various stages of being reviewed and published, we've been working in particular on thinking about how the information can be used in decision making and trying to develop more demand for natural capital accounts. So that's what part of our outreach today is about, to raise awareness and potential uses of the accounts, because really it's the demand for these in decision making that's going to drive their continued production. Next slide. And finally, this is an overview of the various accounts we've been developing in the US. We have a land accounts paper and a water accounts paper. These are part of the SEEA Central Framework, but they're really critical to setting the stage for some of the land and water resources in the US. We've been doing work on ecosystem accounts, like the work we'll show today in the Southeast, also an urban ecosystem account paper that's being completed. And then there's a number of other accounts that haven't been completed in the lower left here, but which BEA has done some work to scope out what data sources are there and how could we compile these for the US. So this is a very broad overview of the accounts we've either compiled or looked into the feasibility of developing. So with that, I'll say next slide and hand it over to Charles Rhodes for the next stage.
Thanks, Ken. So for the ecosystem accounts, one of the first decisions we made was to follow the UN theoretical model out of the SEEA work that they've been doing for years and years. On each of my slides, you're going to see a fairly complicated diagram, and I'm going to ask you to not get confused by trying to appreciate everything, but focus on a few things. So here you can ignore the diagonal arrows, and we're focusing on 1, 3, and 5 as a numbered element specifically. So the concept is going from the bottom to the top, we have an ecosystem asset that with its characteristics and processes produces final ecosystem services as they're used by users in the form of benefits. So the idea within the accounts, and as we move to what an account looks like, you're going to be looking to match those key elements to columns and rows, from the ecosystem asset to the ecosystem service to the user. Next slide, please. So this is the fundamental accounting structure, and you can advance and populate the language underneath there. Yep. So this is the basic structure. So we have the physical accounts on top that separates us from all the difficulties of valuation, which is sort of that gray pipe you see there, and the monetary accounts underneath. So that bottom bubble in the last slide, the ecosystem extent account, is the ecosystem asset, which in combination with its condition produces what we have as ecosystem services. So look, just reading through that second bullet very carefully, the ecosystem asset holds the biotic and abiotic components that in their condition produce the things that when they're used, appreciated, or in accounting terms transacted by economic units, which is us people, those are recorded as ecosystem services. And then there are some protections to make sure that you're not recording the same thing multiple times and adding value in a bad way, as would happen if you're interested in the tiger, but then you're also counting the tiger's habitat at the same time, and then double counting that with the tiger. And that's something we ran into when we were considering some of the pollination services. I'll also note here that off to the right, separated by that bar, there are some things that are cross-cutting. They're very important. They can come into the accounts in different places, and it's proposed that they have their separate accounts to make sure that they're always appreciated. And those are the thematic accounts, and you'll see things like carbon and biodiversity there, which present challenges. And whether or not they always qualify in that box 3, where box 3, the ecosystem service supply and use account, is what we're focusing on next. Next slide, please. So within box 3, you can advance. I want you to look at box B and box E, particularly here. Don't worry about the shading. We can handle that in questions if you want. But you basically have a type of ecosystem unit or your ecosystem asset, which is a classification of the columns above box B that are supplying, from right to left, the rows in the supply table, which are whatever you call your ecosystem services or ecological end products. And then those from the supply, you go straight down to the use for box E, are taken up by economic units or users of the ecosystem services. Populate below with a click. So in general, the contents of box B and E are constrained to be equal even at the row level within the accounting. And that's one of the reasons that you don't want to be counting like bee habitat and the pollination services and then adding up that value in the same thing, because then you'd be double counting and it wouldn't match to the strictures of the standard natural accounting as well. Next slide, please. So one of the ways we vetted what was a final ecosystem service, meaning you were not risking double counting, one advanced click, is that the National Ecosystem Services Classification System has this environment classification that can actually be the classification of ecosystem extent on the left, and then all the way on the right, the user classification, which are your economic units, and then the specific elements, the end products of nature that are used in ecosystem services, where the contents of the boxes in the supply and use table are actually that middle colored arrow, the flows of final ecosystem services. So Nexus gives a good structure, and if you can't map it in Nexus, then it may not be something that fits in the account. Next slide, please. So you see that these colored elements in Nexus can match pretty directly to the supply and use accounts of the form that SEEA recommends, where you have your environment classification over B and your user classification over A through G. And then if you wanted to break it down by extractive use or in situ use of your ecosystem services, you could just have subs where you have like the same type of user would have in situ or extractive uses there. But that matching is what helped us separate final ecosystem services from things that might belong in other accounts. And with that, I'll pass to Katie.
Thanks, Charles. And thanks, Ken, for setting us up. So I'm going to bring us back to thinking about our specific working group and the pilot accounts that we've been working on for the past several years. We had a few objectives in putting these accounts together. The first was just to test that ecosystem accounting framework, the SEEA framework that's been developed by the UN and other countries over the past decade or two, using data from the US. When we started this effort, there weren't any other attempts at ecosystem accounting within the US, and so we were interested in seeing how that worked with data that was available within the US. We didn't do any new data collection for this project. So as part of that test, we developed these pilot ecosystem accounts for the Southeastern US, which is a 10-state region. And then we also wanted to explore kind of what sort of information you can get from the accounts, what questions they can help answer, and how that can be used in decision-making. And when we were looking at what data we had available to populate the accounts, we had a few considerations in setting that up. The first is that we wanted all of our data that we use to be publicly available on a national scale. So even though we're doing this at the moment for just a region of the US, we wanted to have the option to be able to expand all of the metrics and all the data that we use in that to cover at least the contiguous United States. As Charles just explained, the accounts need to be able to, all the information in the accounts need to be able to kind of link back to a certain type of ecosystem. And so we wanted all the data to be able to be separated out by ecosystem type and then also geographically. We have regional level accounts, and then we also developed separate versions of the accounts for each of the states in our study area. And one of the key features of natural capital accounting and ecosystem accounting is that you're consistently updating the accounts, and that enables you to be tracking changes over time. So we wanted all of our analyses to be easily updatable, not too data or time intensive to do those updates in the future. And as part of that, we also avoided using any proprietary tools, models, or data to generate the information in the accounts. One of the major challenges that we encountered when we first set out to put the accounts together was just figuring out, we had kind of all the data sets that we thought might be useful for the accounts. We needed to figure out which of those met the criteria for inclusion in the supply use accounts. So as Charles just explained, that those accounts represent direct use of ecosystem services by people. And then which of them didn't quite meet those criteria, but we could fit into the condition account, which is left more flexible within the SEEA framework, and provides lots of opportunity to capture additional types of information that doesn't quite get to how people are actually using services, ecosystem services, but can still provide important information about the capacity of ecosystems to support those services. So this table just shows you where we ended up in terms of what we were able to put in the pilot ecosystem accounts. So we had information for 2 services that was suitable for the supply use accounts. The first is recreational birding. So we have information on the number of birding days that occurred throughout the study area over our study period. And then also air quality. We have information on the concentration of pollutants that are relevant to human health. And those concentrations specifically in developed areas, so where people are exposed to them. And then we have several more metrics in the condition account. So these are things that are related to ecosystem services, but don't represent ecosystem services themselves because they don't get to that transaction where people are actually using or directly appreciating kind of this component of the ecosystem. So we've got metrics related to bird biodiversity, bird species richness. We have information on air pollutant removal, so that is helpful in interpreting some of that data in the supply use account on air quality. We also have some metrics related to wild pollination, to water purification by natural ecosystems, and to carbon storage. So the paper that Lydia showed at the beginning, which is also linked here, has our full pilot accounts, which include all of these metrics. Because the account tables are so tough to look at on the screen like this, we're not going to show you what each of those looks like exactly, but instead we're going to take some time to step through a few examples using the information from the pilot accounts to understand the sort of questions that they can help answer. So to start with that, I'm going to look at the recreational birding data from the supply use account. To look at how the accounts can help us understand how certain ecosystem services are provided by different ecosystem types. So this is the recreational birding information for 2011, divided by ecosystem type. We use land cover as a proxy for ecosystem type in all of our accounts. And one thing that stands out when you look at this data is how important developed areas are for recreational birding. So more than 1/3 of all the birding days that took place in the Southeast during 2011 happened on developed land. This is mostly happening in lower intensity development classes, so especially on the developed open and the developed low intensity land cover. And this data set that we're using for recreational birding does exclude people who are birding in their own backyards. So this doesn't just represent people, looking out their windows or backyard birding. It's actually that there are good places for birding in close proximity to where people live that people really depend on for this activity. When we look outside of developed areas, forests, open water, and wetlands are also really important ecosystem types for birding in the Southeast. Open water in particular was a bit of a surprise to us, but when we look further into the data, we see that there are several places along the coast where people are going out in boats on kind of birding trips to get to specific places that are known for good birding. So off the coast of North Carolina, for example, if you go out to the Gulf Stream, there's some good birding spots out there, and you can see that signal of these bigger groups going out birding in open water in that data. Okay, next we'll look at how the accounts can be helpful for identifying differences in geographic areas, in this case looking across states. in terms of the potential to provide services. So this is looking at one of our condition metrics related to wild pollination. And this particular metric is the ratio of the amount of pollinator habitat in a certain area to the amount of pollinator-dependent crops in a certain area. So if there is more pollinator habitat available relevant to the amount of crops that need to be pollinated, that indicates that there's a greater capacity to meet the pollination needs in that area. So you can see that there's a big range in this metric among the southeastern states, from Arkansas, which only has about half as much pollinator habitat as pollinator-dependent crops by area, all the way up to Georgia, which has almost 10 times as much habitat as crops. And we found it helpful to look at the data spatially here to see what these metrics are reflecting in terms of what's actually happening on the ground. So we found that states that have high scores on this metric, like Georgia, which is shown in the right here, they tend to have fewer pollinator-dependent crops in total, and they're arranged in smaller patches. So the pollinator-dependent crops here are the orange or yellow patches. And those patches are surrounded by areas of pollinator habitat that can provide that pollination service. On the other hand, states that score low on this metric, like Arkansas, which is shown in the map on the left, they tend to have really large expanses of contiguous cropland. So you can see there's a lot more pollinator-dependent crops in this map. It does look a little patchworky still, but all of that white background is other types of crops. They're just not dependent on pollinators. And so while there is a little bit of pollinator habitat kind of around the margins, there's just a lot more demand for pollination in these areas relative to the amount of habitat that can actually supply that pollination. I'm going to turn it over to Marc now to talk about some of the air pollutant results.
Great, thanks, Katie. So for air pollution removal, the final ecosystem service here is really the reduction in air pollutants. The thing that's responsible for that reduction in air pollutants as far as the ecology goes is the vegetation, such as canopy cover or other shrubs and trees. And that's the stuff that actually removes those air pollutants in various different ways. The user, in this case, is households, so members of households, basically the general public or anybody that's breathing. And of course, the benefit then is if you have reduction in air pollutants, you will have the benefit of reduced risks of adverse health outcomes. For the demonstration accounts here in the pilot accounts, we have several metrics that we used. The first is the removal of the target air pollutants, and we can put that actually straight into the supply and use accounts, while the concentrations of the target air pollutants, the weather conditions, and things like percent canopy cover are all things that help drive that removal of air pollutants, and so those can be placed in the separate condition account. They're not directly used. So down at the bottom here, we did have some changing conditions. So this was the one ecosystem service where we had repeated data for. This is what you would typically see in an accounting framework. We have 2010 and 2015 data for this one. And as you can see at the bottom, the air pollutant concentrations, a lot of them actually decreased over time in the Southeast. The one exception to that was particulate matter 10, which had a slight increase in percent change from 2010 to 2015. The weather conditions in the middle mainly saw increases. So wind speed was up a little bit in 2015, temperature was up a little bit, and we actually had quite a wet year in 2015 compared to 2010. So a 40% increase in the amount of precipitation we saw. And this again is for the whole Southeast. The one condition metric that we didn't have updated data for both time periods, so 2010, 2015, was the percent canopy cover. While that information does exist, the model runs weren't run on the updated numbers for 2015. So we actually kept the percent canopy cover constant for this data, which would be something to rectify in the future to make the results more accurate here. Just something to note. Next slide, please. So when we get to the ecosystem services supply and use tables, in the Southeast region of the US, we saw the pollution removal, the actual rates that we're interested in. Most of those actually went down. Percent change in them is negative, except for particulate matter 2.5, which actually saw a slight increase or a decent increase at 17%. So we look a little bit further into the data on these, into some of the condition metrics related to these removal rates. And we can see that for the various states here, we are breaking it down geographically, various states have differences in concentration differences between 2010 and 2015. And I just want you to look at the carbon monoxide data in both the mean concentration difference and then the second section, which is the removal rate differences. And you can see that increases or decreases in carbon monoxide pretty much match an increase or decrease in the removal rate, which makes a lot of sense. If you then look at the PM 2.5, you can see some of the differences that weather might make. So if you look at Florida and Georgia in the mean concentration differences, you can see that in Florida, PM 2.5 went up slightly, while in Georgia, it decreased. But the removal rates differences, they both actually saw an increase in removal of PM 2.5. So you start wondering, well, why, if the concentrations are going up and down, why are not the removal rates going up and down likewise? And it might be because of the differences in weather. So wind speeds generally increased, temperatures generally increased, but precipitation was actually quite different between Georgia and Florida. And so this could be making the difference between knocking the PM 2.5 out of the air onto the canopy and then basically onto the ground and washed away. Next slide, please. Again, you can start to look at smaller geographic areas. In this case, we're looking at the Atlanta, Sandy Springs, Roswell municipality, a statistical area for that area. And you can start to see that we can combine information from multiple accounts. So here we've got some information we drew from land accounts, the water accounts, our own ecosystem accounts here, and then our urban ecosystems and economic accounts. And I've color-coded these a little differently, so it's not just increases in green and decreases in yellow, it's better and worse. It's a little bit of interpretation of this data. So you might, some of the things have gone up and some of the things have gone down. So if you're losing agricultural land or forest, you may view that positively or negatively, depending on who you are. In the water accounts, the total use of water has been going down in this area, and so water productivity has been going up. But water quality has been going down. So much more monitoring sites reporting significant declines in several different water quality aspects, nitrates, specific conductants, and total suspended solids. All saw a worsening. In the ecosystem accounts, we saw a decrease in the percentage of float paths that are available for purifying water and water quality. We generally saw a worsening of concentrations just for carbon monoxide, and most other things actually improved. Although the removal rates, you can see here that we actually saw better removal rates for carbon monoxide because of the higher concentrations, and better removal rates for PM 2.5, even though the concentrations decreased. And then there's a couple of other ones that we've added here in urban ecosystem accounts. So energy savings due to cooling effect went up slightly, probably due to the increase in temperatures. And the rainfall intercepted by urban trees actually went down. This is probably due to the overwhelming deluge that we had in the later years. So less percentage of that precipitation coming all at once can be captured by those trees. And then overall economically, we saw some increases. So GDP for all industries went up, and there's been quite a decent population increase in this area as well. Next slide. So there are quite a few general things to say about data gaps and research needs that we found out from actually trying to do this. So there is a distinct lack of direct measurements for many of the ecosystem services. Significant because it's hard to populate the supply and use tables, which is really the goal here. In a lot of the ecosystem services, the measurements are just not possible for direct measurements of supply and use, and so we have to use proxy values or condition metrics. When we do have the data, it's sometimes limited in spatial and temporal resolution. And then Some of that data is churned out by large predictive models, or predictive models in these large heterogeneous environments. And when we do have those models, which are hard to come by, they're often extremely data intensive, or they might include proprietary components. So it makes it difficult to run them over and over again like we would want to for counts. Next slide. One of the specific data gaps and research needs for the air purification service is when we looked at what we'd ideally like to measure for the supply and use tables, we would ideally want to see the reduced exposure to air pollutants, not just the decrease in pollutants or how much is being removed. And then for the benefit side, we'd like to look at the number of hospitalizations, healthcare costs avoided due to air pollutant removal. Some of that information is available through BenMap and some other EPA sources, but it's available at different geographic scales. Some of the key questions related to these data caps that we have now is what effect is going to happen when we update the vegetation cover data for this. Hopefully that would provide a tighter linkage between the condition and supply and use tables. And then if you can spatially separate the exposure areas from areas of non-use. So just knowing the air pollutant concentrations isn't quite enough here. You need to know who's being exposed and actually then using the service of that reduction, which could be up airshed somewhere. And then I'll pass it back to Katie for the rest.
Thanks, Mark. Through a few more slides covering some of the data gaps and research needs that we saw for some of these other specific metrics and specific ecosystem services that we wanted to include. So for wild pollination, we would ideally like to have information on how much actual wild pollinator activity there is happening on pollinator-dependent crops. So something in terms of the number of pollinator visits happening per flower. And then if we were able to monetize that, it would look like information on the additional revenue that we can attribute to wild pollination. So there are a lot of data gaps, a lot of things that we don't understand about wild pollination that stop us from getting to those ideal measures. There are many species of wild pollinators in the Southeast and many more across the rest of the US. And we don't know much about each of those species. They each have different habitat requirements and each have different relationships with certain types of pollinator-dependent crops. And so there's a lot of complexity there that we don't have enough information about. As well as information about the relationship between the amount of wild pollinator activity that you're getting on crop fields and then the actual response of crops in terms of their yield. So different types of crops have different degrees of dependence on pollination. And then there's also the question of managed pollinators like honeybees, which in many cases are brought in to provide some of that pollination that's required by these crops. But there's been a lot of research that indicates that those sorts of managed pollinators can't totally make up for not having native pollinators. Moving on to water purification, which I know we didn't show you any examples from, but if we were to be able to include information on water purification in supply and use tables, we would want some information about how much water is actually being used by people and by different economic units, like different industries, and then how much we are actually saving in water treatment costs because of the water purification that ecosystems are providing when they remove pollutants from water, for example, as it runs over natural forests or grasslands or wetlands. And some of that data, especially on the water use, is currently in the water accounts, which will be published soon. But we have a lot of questions remaining about water pollution specifically. So there's questions about the ability of different types of ecosystems to remove pollutants from water, and how that translates once that water actually runs into water bodies into reduced concentrations of those pollutants in the water bodies. We also could use more information about what kind of levels of different pollutants are acceptable for different uses of water. This is also something that the water accounts started to address by doing some initial surveys of experts about kind of what water quality is required for different types of use. And then finally, we need more information about the relationship between the pollutant concentrations in the source water and then the treatment costs to reduce those pollutant concentrations to acceptable levels. And then finally, data gaps and research needs for recreational birding. So in this case, we were able to include the number of birding days in the physical supply and use table. If we were to include something in a monetary supply and use table, we'd like it to be something like the amount of money that's being spent on equipment and travel for recreational birding, so how much that recreational birding activity is contributing to the economy. And there are a fair number of questions on each of those. So while we do have information on the number of birding days, that's currently dependent on some national level surveys that happen every few years, but they're not happening consistently right now, and they're at a fairly coarse resolution. They only go down to the state level. And then there are also a lot of unknowns about the factors that drive decisions that people are making in terms of when and where to go birding. So there has been some research that's related to having more rare bird species in a certain area and how that draws people. But having more of that sort of information would allow us to make more connections between the recreational birding information in the accounts and the bird species richness and biodiversity information. And then finally, to get to the amount that's actually spent on that, we would need to know more about how much people spend on equipment and travel for different types of birding. So even though we excluded birding that was just at someone's home, there's still in our kind of totals there are some local trips just within your town. There could be day trips that people are taking maybe within a few hours of their home, and then overnight trips. And each of those has a different kind of cost profile associated with it in terms of how much people are spending on travel and how much specialized equipment they've purchased for that activity specifically. Okay, so I think that wraps up our discussion of our pilot ecosystem accounts for the US and what sorts of information we were able to include and what we were not able to include. So lately we've been thinking about what our next steps might be for ecosystem accounting in the US. So on the technical side, there's definitely an opportunity for making updates to the accounts and expanding them. There's always new data becoming available that could be useful for these accounts. Since we released them, for example, there have been new land cover data sets which go into many of our analyses, including identifying ecosystem types. So that's something that could be updated. And then as Marc mentioned, there's the opportunity to redo some of those air pollutant calculations with updated forest cover. We'd also like in the future to be able to expand the geographic scope of the ecosystem accounts to the entire continental US, not just our 10-state pilot region. And then finally, the current accounts have information about a fairly small set of ecosystem services based on the data that we had available. But we'd like to incorporate additional ecosystem services and additional condition metrics to meet user interests for people who might be using the accounts for decision making. And that brings me to the other next step we've been talking about lately, which is how we can best support decision makers in using these accounts. So as Ken mentioned earlier, one of the things we'd really like to do going forward is to be able to work with people who are interested in this type of data to help them look at what we currently have, understand how that can be used, and then also potentially make some alterations to do things like creating accounts for specific geographic areas. This could be at the state level. It could also be for land that's managed by a specific government agency. So things like the Forest Service or Bureau of Land Management that have kind of their set of lands that they manage. It's possible to create accounts for those kind of specific geographic areas. And having accounts data is really helpful because you have all the data available to be able to track the status and trends of your critical natural assets through a whole set of accounts. So we've talked about the ecosystem accounts, but it's possible also to pull in information or develop alongside your ecosystem accounts, water, land, carbon accounts, biodiversity accounts. There's many different types of accounts that can hold different sorts of information. And then we, again, like to incorporate what we learn from doing this sort of support and getting the accounts out there to make sure that any future updates you make to the accounts are helpful in making them more relevant so that people can continue to use them in the future. So if you are interested in learning or exploring more about how the ecosystem accounting could be helpful and used in your work, please reach out to one of us. We'd really be interested in speaking with you more about what's in the accounts, answering any questions that you have, and yeah, exploring how that might work out for you going forward. So with that, we'll just say thank you to the Natural Capital Accounts Working Group members who represented the logos on the left here, and also to our funders on the right. With that, I think we'd be happy to take any questions from the group in the time that we have left.
All right, thanks to all of you for a great presentation. We have a few minutes left for questions. So if anyone would like to ask a question, just type it in the chat box and I can kind of mediate the Q&A session. So we have one to start us off here from someone asking, I don't have a background in science or accounting, so much of this language is new for me. What are some ways we can increase the capacity of companies and other entities who also might not be familiar with this type of thing to use these methods?
So I'm happy to answer that. This is Ken. We are, one of the members of our working group was explicitly coming from a private sector background. That was Carter Ingram, and we're producing a paper about the use of accounts in the private sector. So one of the things we hope is that as we continue to produce accounts, these could be a trusted data source that are produced by government agencies that can be used then by businesses, by nonprofits, and conservation organizations, by those that don't have the capacity to develop their own data. So that's one of the things that we hope will come out of this work is to be a trusted data source that can help out in uses where it wouldn't be possible to generate your own data.
All right, this is a quick one. Someone's asking, what is the source or sources for the water purification data?
Yeah, I can answer that. The water purification analysis is topography based. And so basically what it's doing is looking at where there are areas that are likely to contribute to non-point source pollutants. So areas of urban runoff and agricultural runoff, and those are identified by land cover. And then we did some topographic analyses to identify the most likely flow paths that water takes as it moves off of those areas into waterways. And within each of those flow paths, we looked at how much of the land in those areas is made up of purifying land cover types. So things like forests and natural grasslands and wetlands that we know can remove pollutants from runoff water. And so the metric there is just capturing how much of those flow paths that the water is moving over when it's carrying those non-point source pollutants from agriculture and urban areas are actually covered by these purifying land cover types.
We have another question here that asks, I was slightly surprised not to see carbon sequestration included in the accounts. Is this a service you're considering adding, or is this somehow separate?
So we did end up including carbon storage in the accounts, and we didn't have data available in the right format to easily include carbon sequestration as well. And we had a lot of discussion about where carbon best fits into the accounts. I think there's still some ongoing discussion about that, but there is a kind of separate place for that in the carbon thematic account that I think was shown in one of Charles' slides. So that's would probably be the most natural fit for carbon sequestration information. Since we weren't doing a separate carbon account as part of this initial US natural capital accounts, we included the carbon storage information in the ecosystem condition account, but we didn't go beyond that and include sequestration as well.
Thanks. So I have someone here who was actually part of ecosystem service accounting in the Philippines in the past, and they ask, will ecosystem service-based models like INVEST and SWOT be utilized for filling ecosystem service quantification challenges? And how do we reconcile the total economic value framework, which is commonly used in non-market valuation studies, with the SEEA framework?
So I'm happy to answer that. We did talk about the use of common ecosystem service tools like INVEST and SWOT in our paper. And I think it's a challenge in the US because we have some really good disciplinary models that agencies in particular, like USGS, EPA, and NOAA, have developed. And in some cases, those actually go into quite a bit more detail than simpler models. But they may be harder to get their developers to run periodically over multiple years, as is required in the accounts. So I think we have a balance between simple and complex models that we need to account for in the US, although Katie might be able to add more about the Southeast. And then to your second question about total economic valuation, that's definitely being discussed in the context of a revision process for the SEEA, which is that international standard. And there are some important differences between the two frameworks that I won't go into great detail now to allow time for other questions, but there is work underway with the revision to the SEEA to reconcile those differences. Katie, anything to add about the applications in the Southeast? You guys are using invest models for some of the metrics, aren't you?
We haven't used invest models for any of the metrics in the pilot accounts, but we have been using them recently for some other projects. And through that process, I think we've seen how certainly a lot of the outputs from those sorts of models could fit nicely into the ecosystem condition accounts. I think in most cases, the invest models in particular, which are what I'm most familiar with, don't quite get to the type of information we need for the supply use accounts. And I also was just sent privately another question that I think, Ken, you might be able to answer, asking about water quantity and asking whether we'd considered using global remote sensing products like GRACE. I know you did some water quantity work for the water account, so maybe you could explain a bit about what data sources you used for that.
Yeah, we have a water accounting paper that should be coming out sometime in the months ahead too, that was done at the national scale. For that, we didn't explicitly include GRACE, I should say, mainly because it comes at such coarse spatial resolution. I think it's like on the order of 250 kilometers per grid cell. So it's great for tracking the change in water stocks over time. But it is coarse resolution, and it doesn't give you an estimate of the total amount of water. So there's a number of models being developed by agencies like USGS and EPA and others that we hope to get at water quantity better in the future.
I have a question here related to the recreational birding analysis. How are you able to segregate birding activity by land type?
Sure. So as I mentioned, the total birding activity was from a national scale survey, which gave us total number of birding days by state. To be able to get that at finer scale resolution and attribute that birding activity to different land cover types, we used data from eBird. So eBird is a citizen science platform where people, when they go out birding, most people use it to record what sort of species they're seeing. But it also records where they are, where they're going birding. And so we didn't look at species that they were seeing at all, but we looked at the locations where they were going birding. And that's how we were able to get to finer scale for the recreational birding data about where people were going birding and what types of land cover, what types of ecosystems their birding was occurring in.
Great. And then I have a question here about the use of the account. So how might this approach help municipalities increase access to open space and nature in a more distributed way, such as neighborhood parks and green spaces that have been in such high demand, especially now during a time like the pandemic?
So I think that's an interesting question. Most of the uses and the accounts I'm aware of, as they've been used in other countries, they're mostly put together at the national or kind of like subnational, like state type level accounts. And that's how they're used as well. And in the US, we've talked a bit in our group about how, so much of this work that might be using this information happens at a more local level, like municipalities. So I think that's something we'd be interested in exploring if there's interest from a particular municipality, and using some of this would be to look at how the accounts might work at that scale. And I think it would be challenging for sure to have a kind of national level accounts that go down to municipality level, but if specific places are interested in them, it's something that we could help them put together. And you asked specifically about access to open space. So that's not something that's currently reflected in the pilot accounts, but I will say that that data set that Lydia mentioned during her introduction, which is looking at open space access in the Southeast, that is would definitely be helpful along those lines, because it looks at where there is currently access to open space and where there are people who live where there's not access to open space within different distances from their homes, and it kind of highlights places where there's the most opportunity to increase open space access by building new parks. So if you haven't looked at that, I encourage you to check that out. It's not, it's newer than the accounting information, so it was not reflected in the pilot account so far, but it's a type of information that could go into a future update of the accounts.
And I'll just add that another one of the papers in this accounting project special issue that'll be coming out in ecosystem service is on urban ecosystem accounts, but it's for cities with a population of over 50,000. So Mehdi Harris, who's a NASA-funded postdoc, did some work on looking at urban heat mitigation and rainfall interception by trees in 768 of the largest cities in the US. So that's a case where, you know, in the future, you might be able to bridge some of those accounts with some of the work that Katie described in the Southeast, to include metrics like open space access, depending on which table it was appropriate to add those in.
Yeah, this is Marc Russell too. Just to add a little note on the scale thing. So, you know, part of the challenge has always been trying to get metrics down to the neighborhood scale level where a lot of decisions are made. The national scale accounting metrics we use don't necessarily work at that scale. And what you would actually want to do is replace the metrics with different metrics at that scale. You can start to look at, you know, sight lines and other fine scale things when you get down to the neighborhood scale. The EPA put out a neighborhood scale quantification of ecosystem services report a while ago. It includes some of the demonstrations of how you might do that kind of thing, but a lot of that is very manually intensive. So it would be almost impossible to do it without automating it for the nation, for example.
All right, so we are out of time. I want to take just another minute and thank all of our presenters again, and thank all of you for joining us today. We will be posting the recording of this webinar on our website. So if you go to the Nicholas Institute website and you search for NESP, you'll be able to find the meetings and recordings page where this will be posted sometime next week. Thanks again for joining, and have a great rest of your day.